Okay, this is part two. I got interrupted by a phone call at the very end of that one. So I was talking about how my p-value I was answering part C here. I was talking about how the p-value of 0.682 is greater than 0.05. So I have only moderate evidence um, against the null hypothesis in favor of the alternative hypothesis. And so and then because it says summarize your conclusion in context of the study, what I just said, instead of saying the alternative hypothesis, say the alternative hypothesis in words, or say the null hypothesis in words. Um, that way you're putting it in context and not just like the generic alternative hypothesis. Okay, so useful sentences for that part C. Now, the mean group difference is fairly easy to understand, but it's not widely used, in part because it cannot be easily predicted, theoretically. A more commonly used statistic is called chi-squared. So it's the Greek letter chi, and which looks a lot like an X. And then you often can spell chi with a CHI. So you can use the Greek letter or just say CHI, the chi-squared statistic. You can think of this as measuring how far the group proportions of success are from the overall proportion of success. So these standardized deviations from the overall proportion are the squared and summed together across all explanatory variables. We'll do this. So that's if you didn't understand what I just said there, follow along as we do this in a spreadsheet. Okay. So let's see. Now, determine the overall proportion p hat of rooms that reuse towels. That overall proportion is given in this table right here. So that's, for me, that's the 0.434. Now, I'm going to want to use these numbers in a spreadsheet. So I'm going to copy them. I'm going to pause this video and then put them into a spreadsheet. Okay, I'm back. I just copied all these numbers here into a spreadsheet, and I have them right here. Let me kind of make these smaller so I can zoom in. That word is so long compared to the other ones. Just do that. Kind of abbreviate it. Citizen, gender, guest, and total. Okay. So then, the sample size is going to be the sum. I can zoom in now. I forgot. I want to make sure you guys can see okay. Will that fit? Yes. So is equals sum of these two, and parenthesis, enter. No, I don't want that suggestion. But I am going to move it, so move to the bottom right until it turns into a plus and drag it. And then I'm going to, over here, I'm going to have this be the sum of the row. And then end parenthesis. And then I'm going to click in the bottom right and drag that down. And then I get 1625. That's a good double check that I copied everything correctly, is that I got the same total. All right. Now I want the calculated proportions. So calculation proportions of reuse is going to be reuse divided by, and then click B4. There we go. And then I go down to the bottom right here, click and drag, and I'm going to go all the way including the total. And then there's a lot of decimals I don't need that are kind of making things hard to see. So I'll go down 3 decimal places. Okay, so there we are. So now we will, for number 8, we will calculate the standard error of a group proportion by computing p hat times 1 minus p hat over ni, where p hat is the overall proportion found in number 7, and ni is the sample size for the ith group. Find the standard error of the group proportion for each of the 5 groups. So finding the standard error is going to be equal to the square SQRT, start parenthesis, of p hat, and then I'm going to press F4 for reasons of like how I want to drag this, then I do Shift 8 to get that little star, because that means multiplication in Excel. Parenthesis 1 minus that same cell. Again, press F4, and then end parenthesis, and then divided by the sample size of the group. And then that one does not do an F4, and then end parenthesis, and then press enter. And so then I take this equation, click and drag, and I should have those. And again, I don't need to view all those decimal places, so that should be fine there. Okay, one of the reasons Excel is so good for this compared to your calculator is that you can, by doing my algebra like in the cells, I'm not getting any estimation errors. Whereas if you're on your calculator and you're estimating, you're rounding down to 3 decimal places, then you might get some serious rounding error and be off by little bits. Okay, it's also a lot faster than a calculator. Okay, so for number 8, these highlighted answers are the answers to number 8. Your numbers will be different because I changed the numbers. All right, number 9, create a standardized z statistic for each conditional proportion. So remember that a z statistic is going to be equal to, and again you can see that in the Xi book, that pi hat minus p hat over the standard error. So we'll do equals that. I might want to do parentheses. So parentheses, the proportion, the pi minus the portion of the total, and I'm going to press F4, and then divided by the standard error for that group. Okay, and then I'm going to click and drag across there, and again I want to show less, there we go. And so then we get different z-scores for our different groups. Okay, so that's what I have highlighted there is my answer to number 9. Okay, and then so then number 10, which of the 5 standardized statistics are larger than 2 or smaller than -2, suggesting strong evidence the group proportion is significantly different than the overall proportion? Well, for me, I have 0 of those are beyond 2, but you might have 1 or 2 that are beyond 2. Okay. Now, number 11, square each of these values and sum them to calculate the chi-squared statistic. So then I'm going to take equals this squared. So like the shift 6 is called the caret. That squares it. And then, oh, I forgot how I'm going to show you how to do that later. Okay, so I'm going to click and drag here. Okay, and then maybe show less of those. And then the chi-squared is equal to the sum of these guys. And it might just be the sum. Let me double check. You can also see it here. Chi-squared, yeah, it's just the sum of the z-squareds. All right, so chi-squared is the sum of the z-squareds. Okay. So then my answer for number 11 is this number. Okay, you'll have a slightly different number. Now, number 12. What kinds of values, large, small, positive, negative, will a chi-squared statistic have if the null hypothesis is true? So if the null hypothesis is true, then all the p hats would be equal, right? And so if all the p hats were equal, then think about like what would happen then. Okay, what kinds of values will provide evidence against a null hypothesis? Well, that's when there's a lot of difference between them. Okay. Okay, so from the statistic pull-down menu, select chi-squared. So go back to the app. Go back to over here, statistic, chi-squared. Okay. The app will also now display the null distribution for the chi-squared statistic rather than the mean group diff. Determine the p-value based on the chi-squared statistic. Okay. So, there's a statistic right there. All right. So, hopefully, I have 3.16 there. I also have 3.16 there. So if I make it round to the same digits as the app is doing, then I've got the same number. That's a good sign. All right. So 3.16 is what to compare it to. So 3.16. Count that. Okay. Count samples. Oh, that's, yeah. Oh, I put in the wrong numbers. All right, let me change that real quick. I'm gonna pause. Okay, the mistake I made, and let this be a lesson to you, is that I used the data from one of my shuffled tables and not the data from the original. So having made those changes, all of my formulas stay the same, so it's totally fine. But then my z-scores, I have two z-scores that are beyond 2. One of them's less than -2, one of them's bigger than +2. So that would change my answer to number 10. And then my chi-squared would change my answer to number 11. And now that 9.78 matches what I got in the table there. So I use that number. It's a good thing this app has that little warning there. That's nice. Okay, so count. And I have a p-value below 0.05 now. Okay. So determine the p-value based on simulated statistic. Okay. So then my answer would be 0.0457. Okay. How does the p-value based on the chi-squared, there's supposed to be a chi-squared there, compared to the one based on the mean group diff statistic? Are they similar? Is your conclusion about strength of evidence provided by the data against the null hypothesis similar? So it is pretty close, but it's a lot also less. So I had a number that was just over 0.05, which kind of was moderate evidence, but 0.05s are cut off, and now I have a number below 0.05, which means I do have strong evidence. And so that's a little bit confusing. Even though there's a small difference, it's big enough to really change the strength of my evidence. I don't know if that's going to be the same for you, though. Okay, it's an interesting curiosity there. All right, so the primary advantage of using chi-squared is that its null distribution can be predicted well by theoretical distribution. So once again, a theory-based approach could be used without conducting simulation. So below the graph of the simulated chi-squared statistic, check the box for overlay chi-squared. So if I overlay chi-squared, okay, how does the theory-based p-value compare to what you found in question 13? So my theory-based p-value is 0.0443, which is really close to the simulated data. Okay, now let's talk about validity conditions. Actually, let's stop this video and I'll talk about validity conditions in the next video.